up CO63 today, multiplying and dividing radical expressions. And this is the part I was so excited about because on the second page we get to bring back some fun concepts from algebra in order to simplify these radical expressions. So, the first one, 3 root 3 times the sum of 2 root 2 and 4 root 4. What's your strat to solve that? Yes, Gus. You are going to distribute, okay? Whenever you see parentheses, you're thinking distribution, whether it's with roots or with variables or whatever it is, okay? You could do some simplifying within the parentheses first if you wanted to. That root 4 is very tempting. It wouldn't be wrong to do that, but we're just going to stick with what's written here and roll with this. So when you distribute, you end up multiplying 3 root 3 by 2 root 2, which gives us
6 root
6 root 6.
So basically you do.
And then you are multiplying 3 root 3 by 4 root 4, which gives us
12 root 12.
12 root 12.
Yeah, you're wrong.
Okay? And remember, once you do the distribution, which is multiplication, which means the roots don't have to be the same, you multiply coefficient by coefficient, root by root. Once you do that, now it becomes an addition expression. Can we add 6 root 6 and 12 root 12, the way it's written? No, because the roots are different. What is the only way that we can make them the same? Aiden, say what he said.
Say what he said. Simplify.
Simplify. The only way we could get like roots here is by simplifying. Can we simplify 6 root 6?
I mean,
No, because the root 6 does not have any perfect square factors. Root 12 does though, right? So we can rewrite this to be 12 times root 4 times root 3, or 12 times 2 times root 3, because the root 4 becomes a 2, or 24 root 3. So now we have the expression 6 root 6 plus 24 root 3. Can we add them now? No. We simplified, we did all we could. The roots are still different, so we're done.
Oh wow. Oh wow. Oh wow. You're done.
Okay? We're done. That's as far as we can go. What are you seeing we need to do for the next one?
Wait, but couldn't you like,
Oh, hold on. You go ahead.
couldn't you like do the root 12, couldn't you do like root 6 and root 2?
Except 2 and 6 are perfect squares.
Oh.
2 is not a perfect square.
Yeah, 1 times
1.
1 is not 2.
Schultz. That deserves a brilliant. That deserves a brilliant.
Root 2 is not a perfect square. The next one, you see parentheses, so you know we're going to be distributing, but we have 3 different ways we could distribute here. Aiden, raise your hand if you're a crab claw fan. Crab claw cruise. What's another way we could use? Box method. Or old man foil.
Yeah.
Okay?
Old man foil is just not even.
Upside down old man. That's a box.
Upside down old man foil. That's, yeah, for sure.
Raise
Raise your hand if you'd like me to do old man foil as the example. 2, 3, 4. Crab claw. Who's crab claw? Box method. Alright, box it is.
No,
So the box method, you're making a 2 by 2 box because we have 2 binomial expressions. It does not matter which one goes across the top and which one goes down the side. So if you wanted to stay consistent, do what I do. We have 2 root 2 and positive root 15 across the top, 2 root 3 and negative 6 root 2 down the side, but they can be switched. And now we just start filling stuff in. What goes in my top left box here? Top left corner.
4 root 6.
4 root 6. 2 times 2, the coefficients make 4. Root 2 times root 3 gives us 6. What goes in the top right box?
2
root 45. How about the bottom left box? Negative 12 root 4, which we'll do all the simplifying afterwards. Let's,
6
right now,
root 30.
and then negative 6 root 30.
Just going ahead of the curve, aren't you?
Okay? Questions on how I got any of those corners, sections of the box filled? Okay, so now, because we've done the multiplication, we now have addition and subtraction. So we have 4 root 6. Wait, what's that? Oh.
What?
What?
What the fuck? What the fuck?
Oh, you're moving it closer.
On the end stream.
Found the other marker in there.
What in the world?
What in the heck?
Try that again.
What tax?
So we have
What
Is
I would make a new marker, sir.
4 root 6
No.
plus 2 root 45 minus 12 root 4 minus 6 root 30. Right? 4 root 6 plus 2 root 45 minus 12 root 4 minus 6 root 30 are the 4 terms that we have. Can we combine any of those as they're written right now? No.
Well, we can simplify.
Can we simplify 4 root 6?
No.
No. Can we simplify 2 root 45?
Yes.
How?
9 5. Yeah, that. What becomes 3?
2 times root 9 times root 5,
6 root 5.
or 2 times 3 times root 5
James.
becomes 6 root 5.
Ooh. Next one.
Okay? Can we simplify negative 12 times root 4?
No.
How?
Yeah. The 2.
Root 4 is a perfect square. It becomes negative 12 times 2, or negative 24. Can we simplify negative 6 root 30?
Yes.
No. 30 has no perfect square factors. 2, no. 15, no. 5, no. 6, no.
4 to
3,
2.5.
no. 10, no.
Wait, no.
Okay? So, this one we could not change. This one we simplified. That's our new term here. This one we simplified to get a new term there. And this one we could not change. So putting it all together now, it really doesn't matter the order you put the roots, just so the constant is last. So we can still just rewrite this. Why is this doing this? That's so weird.
It's the pen
It's the best.
What is going on?
Very well.
Oh yeah, it does.
That's just the
All right, we'll do it here. 4 root 6 plus 6 root 5 minus 6 root 30.
No, minus 24.
Because the 24, that constant has to come last.
Dang it.
Wait, so it's
6.
How do you do anything? That's it.
You can't do anything more.
don't,
You're
Hugo.
done. Yay, math.
I thought the constant.
Blue math.
Not with roots. The coefficient.
Multiply the math, show your work.
What's that?
Does 24 have to be at the end?
Negative 24 does, yeah.
Now let's do another baby.
Just how it's written.
Let's do the last one now. Would it be wrong if I put it in the third spot?
Okay. The other part of this objective is the division piece. It says you can multiply and divide radical expressions. Here's the good news. You've already divided radical expressions. I just didn't tell you that's what you were doing. Okay? When you see something like, for example, when you see something like this, where you're taking 12 root 10 divided by 6 root 2, this is basically simplified. It's basically CO61 all over again. You were doing this in CO61. You were dividing radical expressions. What would you do here?
You would do the 12 and the 6 and the 10 and the 2.
Yeah,
12 divided by 6
that's 2.
gives us 2 root 10 over 1, or nothing, root 2, because 12 by 6, 2 over 1. Okay? Yeah?
Wait, with no reaction.
Yes.
That's review. That's review. So
It was review, rationalizing, we only got like 10 minutes left, so.
Wait, is it rationalizing or do you like multiply by?
We'll have to do that here, so we'll just save that thought. And then root 10 divided by root 2
Root 5.
Root 5. And so 2 root 5, do we have anything left in our denominator? No. So we don't have to rationalize, we are done. Like I said, you've done this before. Okay? You've done this before, I didn't tell you. Audrey? We're not gonna do the middle, no. Okay? What the middle is review of is like the fourth one here. So where you have 25 root 8 over 7 root 5. Okay? Here we were able to simplify the 12 and the 6, our coefficients. Can we simplify 25 over 7? No. Can we simplify root 8 over root 5? No. So what can we do?
Nothing?
False.
Nothing?
We could rationalize. Do you want to do that first?
Do the 4 and 50.
Or what else could we do?
Simplify.
Simplify what?
The 8.
The 8. Okay? It's a good math tip to wait to rationalize to the very end. Because sometimes, it's not going to happen here, but sometimes the root that you would have to rationalize ends up canceling out. Like we did here. If we had rationalized first, it would have been a lot of extra work that would actually happen. Okay? So I would just save the rationalizing to the very end, because you never know what simplification might happen along the way. So Luke is saying, let's simplify this root 8. What does root 8 simplify to be?
4, 2.
4 and 2, or 2 root 2. So now our numerator becomes 25 times 2 root 2, which is 50 root 2, over 7 root 5. Okay? Like I said, it wasn't going to happen here, but it did here, where it ended up canceling out. We do still need to rationalize, but at least our roots are a little bit smaller now. How are we going to rationalize this?
5.
Emily?
So you could do root 5 times, root 5 over root 5.
Yes. Root 5 is the root that we want to remove. Let me, a little more space here. So we had 50 root 2 over 7 root 5. We have to multiply by that root 5 over itself, which in our numerator is going to give us what? 50 root 10. And in our denominator, this, what?
35.
Why 35? You're right. But why?
Because
you have to
multiply the rationals.
Yeah, and then you go to 25 and just to 5.
Right. Because the root 5 times root 5 becomes root 25, which reduces to 5. And 7 times 5 is 35.
And then can't you multiply by 4?
We're starting to get it, yes. What else can we do here?
50 and 35.
50 and 35 can be simplified as well,
10 over 7.
right? 50 35ths is equal to 10 sevenths. So final answer, 10, there's our 10 sevenths there, and our root 10 is in the numerator. Five root 5 becomes 25, which is 5, but don't forget about this coefficient 7.
Oh.
Oh, no. Look at the third one.
Okay. Let's just take a look at the second page, see what's there for us.
We have to do that?
Oh.
You're an op if you make us do that.
Pick one of these 6.
The last.
The last one? No, the last one's not too bad.
Fifth one. No, last one. Realistically.
Middle.
No, just from this 6. Just from these 6. I'm not going to assign you. Not going to assign you the last.
First one.
Top middle one.
Wait, the last ones are not on your side?
Top middle one?
Top middle one. Top
First hit, 80.
Top middle one.
Top middle one, okay.
What are we doing?
Don't worry about it. So x root x over x cubed.
Wait, why am I not wearing should simplify that? I'm smarter with these.
What can we do? What should we do? Mario,
You should simplify the x.
to what?
X root x.
So we don't need to simplify x cubed because there's no root over it,
Yeah.
right? What can we simplify?
The root over x.
Because remember, what this is really saying is x root x over x times x times x, right? We've got 3 x's in the denominator. How many x's do we have in the numerator?
1, so we cancel out 1.
Yeah, so x, oh, yeah, root x.
That leaves us with, what is going on in the middle of my board here all of a sudden?
Flying away, boy.
That leaves us with root x over x squared.
Oh, well that.
Is there anything more we can do?
Yeah. Nah.
No, we're done.
Yeah.
Great job, Ed.
That's it.
Hey,
You
it
can
looks
down
hard,
assign
babe.
homework, Schultz.
Yeah, just 'cause it looks hard doesn't mean it always is, right? This is
I want to know how to do
It didn't look hard
That
though.
doesn't look that bad though.
Audrey. I'll let you know shortly. Let's pick another one here.
The fifth
The
one.
middle, first second row.
Middle second.
No, you got the first one. Chance.
Bottom left.
Bottom left.
No,
Okay.
like 4/3 divided by.
No, we're not doing those. I'm not going to sign
Middle
those.
then. Bottom middle.
Bottom middle. 24 root xy.
Yeah.
That is
Okay.
so easy.
So starters.
Wow. You did the last.
I got 3 minutes left. Let's go. 4. What can we simplify?
The 5.
24 and the 2.
The 24 and the 2. What does that equal?
12.
12 or 12 over 1. So now we have 12 root xy over nothing.
Or root x.
1 times root x to the 5th.
What becomes?
What can we do now? Evan,
Root x5.
which is what?
Schultz.
I don't remember.
X.
X squared.
Could you
root x.
multiply it by?
X squared. You can cancel it out.
X squared root x, right? Because of that odd power, we subtract 1 to get that perfect square, x to the 4th, which becomes x squared, and because that power is odd, we know we'll always have that extra root x, or root y, or whatever it is.
And now you
Now what can we do? Emmett, not yet. This one works out well for us. This is why it's good to wait to rationalize the very end. Take a look at what we have. There's something we can do vertically before we have to rationalize. Emmett, do you see it? Pass it on to Luca.
Oh, you can cross out the x's and the root.
We can cross out the x's in the root. Right? So that leaves us with, in our numerator, 12 root y. All that's left in our denominator is x squared, and we are done.
So easy, guys.
No, it's once you start to see and recognize what can be simplified, it's not that bad. Your homework for Monday, listen carefully please. Your homework for Monday. The 1 foil crab claw box method we did not do. There was one we did. The one we didn't do is homework. And the other 4 on this page. Don't worry about the bottom row. So only 5 questions for Monday. The old man foil crab claw box. And then the other 4 on this page. So 5 questions total. Aiden, is that more than 5 questions?
Yeah.
Then you do not need to do them. Okay? All right, that's our math. Emily, stay in the room.
Unlike an unscrap.
Come on.
Like this is